In this problem, we are going to be performing a reaction between our sodium amide and our geminal dihalide. Now this structure is called a geminal dihalide because it has two halogens on the same carbon atom within the same structure. And whenever we see a geminal dihalide and excess sodium amide, we know we are going to be performing two consecutive E2 reactions, where our beta hydrogens on our beta carbon are going to be targeted by our sodium amide in two E2 reactions. So in the first step, the negative charge on our nitrogen atom is going to target one of our beta hydrogens, the electrons from the bond are going to fall down, and one of our chlorine atoms is going to leave as a good leaving group to form a double bond in our structure. Next, our sodium amide is going to come back to perform that second E2 reaction, where again, the electrons on our nitrogen atom are going to target that beta hydrogen, the electrons in the bond will fall down onto our structure, and our chlorine atom will leave as a good leaving group to form a triple bond. But because we still have this relatively acidic hydrogen atom in our structure, and we also have more sodium amide because our problem states we have excess, we are going to undergo a proton transfer now, where the electrons from our nitrogen atom are going to be attracted to that relatively acidic hydrogen atom, and the electrons from the bond will fall back onto our triple bond to form an acetylite ion. Now, in order to turn our negative charge back into a neutral species, we are going to enlist the help of water, where the electrons from our acetylite ion are going to be attracted to one of our hydrogen atoms in water, and the electrons from the bond will fall back onto the oxygen atom to form our neutral final product.